chance. Put the film as usual.
Co nam zabrałeś, stary roku? A może coś dałeś, o czym ja nie wiem? W plebejskiej wierze oznaczyłeś, kto jest panem, a kto nim nie jest.
Dzień dobry Państwu. Dzień dobry moi goście. Robert Domenico. Hello Robert. Nice to see you here.
Hello Andrzej. Nice to be here. Thank you.
Cześć Tomku. Ja powiem dwa słowa po polsku i potem oddaję Tobie głos. Przedstawisz Roberta. Ja może na początku też po Tobie powiem parę słów, a potem przechodzimy tylko na język angielski i jeżeli ktoś będzie chciał, to możemy potem opowiadać w następnym programie o tej idei, tym wynalazku Roberta. I give you the voice, Tomek.
So, good afternoon, everybody. Good afternoon, Robert, and good afternoon, Andrzej. Well, we're going to talk about something very, very strange, so to say, because a machine that can save the world. I mean, at least a piece of it, and what it can do generally is save us from carbon emissions to a large extent, give us some job opportunities, and protect us from COVID-19. So, and it's very simple because it's a development of a improvement of a very old idea, but with our current technology, it can do it much cheaper or less expensive than its older versions used to do. And this way it can be affordable to the extent that can be used in every home. So maybe I'll leave the microphone for Robert to explain what it is actually. So please say a few words, just a general description. What it is? What is it?
Okay, Tomek, thank you. I call it cargo fish. It's your idea as well as mine. Tomek and Andrzej both arrived at the same high-level strategy that today's technologies are perhaps far enough advanced from years ago such that an additional utility system, instead of to deliver water or power or energy in natural gas, instead a delivery system, a utility that can deliver, if you will, containerized parcel. As in the US, in most bank and pharmacy establishments, there is a drive-through, and the outside lanes of the drive-through typically have a pneumatic capsule, just for that short distance, 10 or 20 meters into the building, the bank or the pharmacy. And so for the convenience of automobile drivers not to have to park and walk into the building and subsequently walk back out and get into their car. Instead, they use the drive-through, and for that, there's numerous, very common pneumatic tube systems. But the characteristics of pneumatic tube systems, they don't lend themselves to a network in the way that transistors and computers allow the internet and mobile. And certain electronics have advanced. People have seen radio-controlled cars and radio-controlled planes and drones, and many of the enabling technologies for that, if applied instead to an enclosed and dedicated rail system. It masquerades as a pipe, but it's not pressurized and full of what it is delivering, as in hydraulics or ventilation or any other thing. It's simply a very miniature subway or slot car. It's an older toy from 60s, was popular, still get raced. But instead of being a toy, it's a tool. So this slot car is about 1 meter long, and it runs inside of its own enclosed track network, a dedicated network that's only about 1/5 of a meter in diameter. And I arrived at these dimensions just on the basis of my own best strategic evaluation of where to start. This will keep the installation costs low, and yet will allow the shipping of we bottle milk by the gallon. A lot of milk in America moves in a 1-gallon jug, and this system is designed to be able to lay 2 1-gallon jugs on their side, and that fills 1 payload. So imagine, if you will, that in your kitchen of the future, your refrigerator and freezer as they exist today really become obsolete because they don't refill themselves. And your new appliance one day will be like your refrigerator and freezer today, but something also like a vending machine, so that when you need more groceries, you will simply either have scheduled deliveries already, or you may reach out for, an immediate dispatch. Let's have ice cream for dessert tonight, last minute decision. And after it delivers your fast moving consumer good, scheduled or otherwise, that vehicle will stop down under your new trash compactor and pick up a container of trash, which your trash compactor compresses and makes ready for outbound shipments. And so if you really want an abstract what it correlates to, every large living thing has a blood system. None are without it. And no organ in the body breathes but for the lungs, and all the others get their oxygen via the blood. And no organ pulls waste out of the bloodstream but the kidneys, and all the others just push the waste into the blood. And all this is a way to optimize and leverage as best we can the available technology to make a low cost, highly energy efficient, highly reliable, and convenient utility that will make the world more livable for us and without consuming so many resources. So I apologize that it's a bit of a lengthy description, and sometimes that's as short as I can summarize it. But I wanted to try to really give you a sense of, because I appreciate that you're here and take the time to listen. So Tomak, thank you.
Yes. If I can add a few explanations, hopefully to reword it in just different words. What it does is a similar thing to this pneumatic post that we actually have in Poland as well, mostly in hospitals, to transport blood samples from one ward to another. But what it does, instead of having these capsules reserving a track for itself, and thus having several hundred meters of tube reserved for just one capsule, you can put those vehicles one after the other, so they can actually fill up a tube. So because of that, depending on what speed they're traveling, if it's like 50 kilometers per hour, you can have more than 1 million vehicles traveling over one pipe. because thanks to modern technology, you can have those vehicles joining the traffic without stopping, without slowing down. You can control them synchronously. You can have the vehicles in a row, drive a gap between themselves, and the other vehicle just joining in. And the very thing that we have this modern technology of synchronous control makes it possible to transport enormous quantities of goods through a relatively small pipe. So in Poland, it will be 20 centimeters pipe is a typical drainage pipe. You can buy it about like 100 zloty per meter, about some $25 per meter. And building a track like this costs about 1/10 of what a bicycle lane would cost, never mind a road with cars between on it. And the problem is that people usually do their shopping by car. So you can imagine a car traveling with a speed of let's say 30 meters per second, and having 2 seconds headway in front of it. It'll occupy about 60 meters it'll need 60 meters in front of it. And with a lane of about 3 meters and something, you would have 200 square meters per one parcel of shopping that this car is bringing. And instead of 200 square meters of tarmac, you have just 1 meter pipe. It's a big difference. Yes, Andrzej.
Let me say a few words in Polish, because we got some question and request for the translation. Drodzy Państwo, audycja będzie dzisiaj po angielsku, ale oczywiście należą się słowa, przede wszystkim wytłumaczenia. Robert i Tomek rozmawiają o nowoczesnej formie przesyłania zakupów. Konkretnie o zakupach mówimy, a wzięło się stąd z miłości do ochrony ekologii, do oszczędności benzyny, niespalania takiej ilości węglowodanów, produktów naftowych, przepraszam. I generalnie żeby nasze niepotrzebne jeżdżenie samochodem po zakupy uprościć, i takim właśnie wynalazkiem jest wynalazek Roberta de Domenico, zwany Cargo Fish. Ja tutaj Państwu załączam adresy, linki, na którym również po polsku jest wytłumaczenie, co to jest, z czym to się je i dlaczego to jest takie ważne. Będzie następna audycja, kiedy będzie to mieszana audycja angielsko-polska, i myślę, że tyle wytłumaczenia dla tylko polskojęzycznych naszych widzów. A teraz oddaję głos moim rozmówcom. Tak powiedziałem, będę załączał tutaj linki, pod którymi Państwo będziecie mogli więcej na ten temat poczytać. Jeżeli kogoś interesuje ekologia, oszczędność i nowoczesny sposób robienia zakupów na przykład. Okay, I did my job. I explained more or less, just roughly, about what we are talking about. And because I destroyed Tomek speech, so I give you back the microphone.
No problem. That was just the chunk I just wanted to finish anyway. I've talked a little bit about this system on Facebook with people, and there were several questions. One of them was why 20 centimeters across? Because this for some people it seems to be slightly sort of on a tiny side. And did you actually try all kinds of American groceries to fit into the container of the 20 centimeters? And did you come to your conclusion this way? How did you sort of like measure it? Did you what kind of groceries did you consider or try in it in a system in your model?
Oh, well, I mean, there's going to be a cost to installation or running of any line. And no matter how thin it gets, there'll be some baseline minimum cost. And so you do want something that's as big as can be while still being affordable, while still consuming small energy instead of a lot. Obviously, a 5,000-pound truck is overkill to go and get a 1-ounce pack of cigarettes. That's the beginning. That was the starting point. And it actually, if you were to take, well, I'll stick with the eighth scale. So a gallon of milk fits in an 8-inch or 20-centimeter diameter. And well, also, not every bit can be installed, cut, and cover. So you dig a ditch, you put in pipe or track, 2 side by side, perhaps 2 over under, and you finish, you cover, and to ensure some cover for protection. And you don't always get to do that. In some cases, the existing things that are already there, in case by case, you may want to tunnel beneath, such as the gas company often does when they put a service riser to a new service in another home. A homeowner says, I want gas. And they'll use a pneumatic driver to pull a small diameter gas feed. Lately, distribution in the U.S. is about 50 PSE, 50 pounds per square inch. I'm sorry, I'm not unprepared to convert to pascals or newtons. I do most of my engineering
by 15.
Okay, and
50,
but about
50
three
so it will be like
atmospheres.
3 bar.
3 atmospheres, 3 bar, and so there. I anticipate there will be places where horizontal directional drilling will be the right way to install, some run or other. Well, in the U.S., there are 2 major manufacturers of horizontal directional drilling equipment on these scales. I don't know how big a scale they go. They're called the Vermeer and Ditch Witch. And the smallest horizontal directional drilling rigging machine they make will pull back a 12-inch head, 35 centimeters, behind which you can pull a 20-inch pipe. So now we have 2 good reasons. The smallest and least expensive horizontal directional drilling, it could do smaller, but it'll go 20 centimeters. So pull as much as you can if you're going to do it. And then the last reason, investigating the cost of available materials. If it were smaller, if it were only 16 centimeters instead of 20, some of the high-density polyethylene lines can be acquired on a big roll, on a coil, and that would be a lesser expense. But 6-inch diameter is even smaller, and it won't fit a standard gallon jug of milk. And I thought the sweet spot was closer to 8 inches, even though I would expect that the pieces would come in lengths of approximately, well, whatever 40 feet or 53 feet comes to. That's about 13 to 16 meters, I guess. So even in spite of, so it's always a list of these are the advantages and these are the disadvantages, and then they try to pick the optimum. And so one thing I could say is my cell phone. It only delivers 0s and 1s, which is pretty small size. It's nothing but signal. And yet I find my cell phone is a useful thing, even though it won't deliver the kitchen sink. And so it is with last mile distribution. I can fit nothing in my mouth that will not fit through an 8-inch pipe. Or even smaller.
Yes,
My foot.
yes.
I can fit my foot in my mouth.
Yeah,
I probably
because,
just did.
Well, because what we're talking about is like loaf of bread, definitely a bottle of wine. In Poland, probably for many people, it'll be a bottle of vodka, some fruits. If the vehicle itself, I mean, if the container was 1 meter per 20 centimeters in diameter, you have 30 liters of course the container that travels in the pipe will be slightly smaller than the pipe itself, but this is the kind of volumes that we're talking about. I suppose the retail industry would adapt a little bit and put things in lengthy bars rather than bulky 6-packs or 12-packs. Because
like that.
if you
because
if you talk about beer, I mean, you can put them in a row. Yeah, you don't have to put them in side by side. Yeah,
I like that because if I could add just a little. In Roman times, galleys that were rowed were more common than sailboats. The sail would only be put up in certain directions. And the shape of the hull of the ship and the commerce of the time, things were moved in ampules, which were a large pottery with 2 handles on the top, almost 1 meter long and pointed at the bottom. And they would be loaded into the ship much like shingles on a roof. And when they came to port, they could stick the pointy part into the sand. And ampules were for olive oil, for flour, whatever else they traded, they used them. And in the time and the age of sail, things, by then they were moved in barrels. And there was a different size barrel for everything, a peck and a bushel and a many different. And the barrels were bulbous in the middle because they were moved by hand. And if you took a modern 55-gallon drum, which is completely cylindrical, and if it was filled with, oil or worse, water, even heavier, if you were rolling it, you can barely change its direction. But back then, the barrels were bulbous, and you could spin them like a top. And those barrels, because of the way things were shipped, and now today with trains and trucks and forklifts, everything has gone to square because of the forklifts and the pallets. So the adaptation, what adapts to what, last mile of distribution is the most expensive leg, the most inconvenient, the most energy intensive. And if the most appropriate solution to last mile solution begs for 55 centimeters long, no more than 20, perhaps 18 centimeters around for the actual payload, then many things will be packaged like that. Cereal, instead of coming in a square box, will come in a cardboard tube. So
yes. I can hardly think of anything that cannot be prepared like this. Of course, I mean, certain things would change. I mean, you would have to have a pizza would have to be sort of like rolled like calzone, sort of.
Already sliced. Right? When they asked Yogi Berra about his pizza, they said, "Would you like that cut into 8 slices or 6?" And Yogi says, "Better cut it into 6. I can't eat 8."
Yeah.
But yeah, you would slice it ahead of time and stack it in something like a honeycomb for pizza slices, and you could send the whole pizza, it would already be sliced.
Yes.
So
yes. Yes, there was there were lots of other questions from the people that I talked to. So there was a question: battery or power rail? So can you say a few words about your choice? Because the thing is, because I'm still thinking about it, is because like batteries, the lithium ion batteries have went down. The price went down over the last 10 years by a factor of 10. It's expected that within the next 10 years they will go probably again down by a factor of 10. Do you think this could change your plans because
No.
because you have assumed that you need a power rail? But well, maybe you can just explain it because this is
Okay.
sort of like a battle nowadays with battery or power rail.
Yes,
In every industry, actually. Yeah. I've seen like buses in my city. Back we used to have trolley buses, but now we have buses with battery buses with the sort of like a pantograph that charges them at every bus stop. But yeah, sorry.
Well, so we've seen and heard discussions about the merits of batteries. And so let's go to the fundamentals. To begin with, neither is actually a source of energy. The only battery that is a source of energy is what's called a primary battery. A primary battery is made chemically of energetic stuff, and you hook it up, it feeds your device, and when it's dead, it cannot be recharged, it's thrown away. And those chemicals are expended the same as if you would burn gasoline. It's expended, done. Secondary batteries are able to be recharged, but you have to use energy to charge them. So the batteries are not a source of energy, they're a vehicle for its delivery to where it's being used. Now, the rail or the overhead catenary in any electrified rail system is the vehicle through which electrical power is distributed. In fact, the electrical grid, it's the vehicle, it's the machine for the delivery of power to homes, factories, battery chargers. And so that step is required. Already, you must get the electrical energy delivered. Now, in a portable device like a cell phone that's going to be carried in my pocket, and there's no easy method or reason to keep it in contact with something, a conductor made of metal that can be energized to deliver its power, then I need a battery. But back in the day before cell phones, when the telephone was mounted on the wall, then a battery was a bad idea. It was more expensive than just simply supplying the electricity. Now, it may be valuable as reliability and a backup, but think about it. On a telephone system, if the circuit is not conducting the electricity, nor can it conduct the information. And so no old style telephone used a battery. They were on an energized communication circuit, and when the power was available, so was the communications. It needed it all, it worked. And when the power was not available, it did not. Now, the batteries came along because of cordless phones, etc. We already spoke. But more fundamentals about batteries. Unfortunately, every rechargeable battery costs 5 to 20 times, generally, range, more than the electrical energy that you will ever pay for to recharge it in its entire useful lifetime. And so to use a battery, it makes your energy portable, but it multiplies its expense by a factor of roughly one order of magnitude, just say. The cheaper your power initially, the greater the multiplier of making it more expensive. If your power is very expensive already, maybe it only triples it or quadruples it. But the best of rechargeable batteries may be able to fill and empty 2,000 times, regardless of chemistry. Nothing has ever gone beyond that in any of the literature I've ever seen or any of my experience in naval submarine service, where we used main propulsion emergency backup batteries, and other things that I've experienced both as a hobbyist on the side and in a career in energy. And so a battery is a useful thing when and where you need it. But this system is an enclosed delivery system for other advantages. It is a rail system for other advantages as well. Most notably, a reduction by a factor of 10 in the coefficient of rolling resistance as compared to a rubber tire. So there's already a reason to make it a rail system, because now you can push it much more easily. And if it's a rail system, you already have a conductor. And if you already need to have it enclosed, you already have an insulator, so that even though you're below ground, you can run an energized circuit. Now, that all said, there will be a battery on board for ultimate reliability. But in ordinary operation, that battery will be in standby, such that when power goes dead to the track, the vehicles can keep running for hours. How many hours? Well, the economics of the application, I leave that up to empirical determination. Depending on the installation, you might want a highly reliable system that'll continue to run for a day or two without power. Maybe a few hours would be enough. That will simply make a difference in the cost of operating the system. But the batteries will last a lot longer because they will not be charging, discharge. They will only actually cycle when they're needed. In fact, and I don't know if you're going to be able to show the clip of the demo video, as I am not at home with the prototype right now. I'm in Philadelphia, Pennsylvania, adjacent to New Jersey, where I live. I'm at the makerspace where I build. And there will be additional batteries, but they will be stationary wayside on the track. So that's quite a bit to digest. Don't jump to the conclusion that, well, maybe it's not the most optimum. Maybe not. I don't think I've proven anything. But I'm just offering, this is what I arrived at is worth trying out and seeing how good it goes. And
it's a good point. Yeah.
Well, we have some people leaving now, so maybe we will come to the conclusion, and let's find another time to continue.
Yeah. Just if I can there are some. I have some still some questions. I forgot about them. Let me think. Sorry. So there was the batteries, the size.
How deep?
Ah, yes. Because I was. There was another question that it was asked by somebody. Is it better to bury or better to suspend the pipes? What do you think is better in what circumstances, or always? How do you find it?
in most cases, it'll be better to install subterranean, just shallow, the first 18 inches. What is that? Less than 40 centimeters. It does not have to be deep because it's not filled with pure, fresh water, so it's not in danger of freezing. It's not pressurized with natural gas, so it's not a danger or a hazard of exploding and burning people. It's not energized. It's not going to shock people. It is energized, but it's low voltage. And it would be, in most cases, less expensive to install underground, but here and there, it would be good to go above ground. In New York City, there was a pneumatic postal system that ran in service half a century until about 1952. In the one place it distinctly went above ground, it went across the Brooklyn Bridge from Manhattan into Brooklyn. And that was a very difficult part of the trek because underground you have thermal stability, generally speaking. You have security by obscurity, and those are two advantages. And also the first 35 centimeters of underground is actually lightly occupied in comparison to from centimeter 50 to 100, 150, many water lines, sewer lines. So that is a more crowded space. Although any depth would be fine, case-by-case installation. But underground would be the cheapest. The same as underground is the cheapest for sewer, underground is the cheapest for water. Here and there in the Alaska of the U.S., there are some above ground sewers, but they have to be insulated. They have to be heat traced.
Yeah.
They're above ground for a reason. But if they were ordinary geography and climate, then it would be cheaper below ground. So some things are cheaper above, some things are cheaper below. In most cases, this will be cheaper below ground.
Yeah, they definitely look better underground, But I was sort of thinking that maybe in some locations that have like power lines above ground, rural, for example, you can actually run it along the power line, and it does actually contain a power line, so it can be run instead of power line. Did you think about that as well?
Yes, I have. And those integrated and symbiotic relationships, as they unfold, we'll find out which of those make the most sense. But I like just simply getting the starting applications right. You see PRT most often in some sort of pilot in some high demand place like ultra PRT at London's Heathrow Airport. Now, of course, we know that airport parking is among the most expensive. Center of New York City is expensive parking, but so is at the airport, even the long-term parking in Philadelphia is $12 a day, I think. You see them maybe in a college campus like the Morgantown, West Virginia installation put in the U.S. around 1970, 71 at a taxpayer subsidized cost of more than $100 million and has never made revenue to cover its O&M, let alone the capital, and probably never will. That's not where we want to go with this. If we look at water and sewer and gas systems, many of them in the U.S. at least are operated by private companies. Many of the others are a government organization, but most, if not all of them, are completely paid for by user fees for that service. They do not take a sip of some other tax revenue, like gasoline tax paid for by automobile drivers subsidizes the New York City subway so that toll payers can pay $2.75 instead of $5 because their revenue does not cover their cost of operations. But that's not the case for water, sewer, and gas. They're not subsidized elsewhere. Now, I don't know. Maybe there is some federal program trying to replace aging, cast iron steel before we have another catastrophe. Every once in a while, there's an explosion. People use their lives. It's terrible. And modern materials such as high-density polyethylene piping really have demonstrated the ability to perform probably for a century reliably. So, but I digress. Sorry. We're been at it a while. What can I say?
Yes, I've actually started with a PR in my interest in PRT and sort of like reading a lot about it, and then I sort of had this realization: bloody hell, why should you transport people going to a shop rather than you should transport the goods that that people want to bring home? So, and you can do it, at a fraction of a cost. And actually, and the same system will take the rubbish away. So you have two things at the same time. There were some people that were, for some strange reason, I mean, on Facebook, you always find some people sort of like crazily opposed, claiming that, well, I mean, the current system functions pretty well. I mean, but what I've calculated is that in order to have the same coverage of an area, like this piece of a tarmac, the car would have to transport about 6 tons of goods. And the question is, how many cars actually transport 6 tons of goods over the tarmac? Not that many. And but I was always also wondering about one thing. sort of like the combination of the cargo fish with different modes of transport. Do you think about making those containers actually removable, and so that I would fit in a certain quantity into a standard shipping container, or some automated system to put them into the railway carriage, or just, because at what point does it make sense to transport between different cities, or like 1,000 kilometers? Would you say that you transport like the last 5 kilometers, and you have reloading stations where the cargo fish containers go to a bigger container? How do you sort of envision this problem? With reload or don't reload?
Well, I mean, you want the long-term vision, you want the path to get there. In the short term, you want to go after the portion of distribution that's the biggest headache right now. And so the distribution system is already optimized as best as we as a society know how to optimize it. We're willing to pay more for convenience. We do. Obviously, we're willing to. But we don't want to pay more. We want to pay as little as possible. And, this is a solution that's a group thought of 7 billion inhabitants of the earth. And this will start where it's the most painful. When you go to a restaurant, we've all eaten at a restaurant, and in the U.S. it's customary, I think, 18% or perhaps a 20% tip for the staff. Now, if you sit down and make some careful observations about each trip the waitress makes is about 30 meters, and each time she may be carrying 3 kilograms, but probably only averaging 1. And then this many kilogram meters are being carried by the waitress. And when you add it all up, the cost of moving the food from the kitchen to the table is in the neighborhood of $30 million per ton mile. And waitresses don't make the highest salary. This is a very expensive leg of the distribution system. Now, admittedly, the waitress does other things, but you will find systems such as cargo fish, not the same propulsion. You will find them in Alston Towers in the UK, somewhere in the Midlands. It's a sort of an amusement park. They have a high-end restaurant, and it's sort of a part of the entertainment. The kitchen is up above, and there are these 2 stainless steel rails, and the chef puts things in little crock pots with a little lock lid, and they send it down, and the families there and the kids, and forgive me, but it is typically little boys. They love it. Wow, look at that. I'm going to be an engineer when I grow up, and I won't know how to relate to people. I wouldn't wish that on anybody. But
yes, and
you cover the most expensive first, and then yes, the transshipment. Absolutely. Imagine a system that slowly covers Philadelphia the way the pneumatic post used to once cover Paris, France. There was a 32-kilometer diameter postal system used to send a petit bleu, they called it. The diameter was some 3 centimeters, I think. It operated until 1972. You have Philadelphia covered, and many high-stakes things that used to be $50, send a bicycle courier. Right now, it's got to be there in 2 hours. And now it will get there in 5 minutes for a cost of 50 cents, and that will be profitable. And then, okay, that's so good. Let's do it in New York City too. And now, if you look up online, what's it cost for get it there now? This is legal documents. It has to be hard copy. Philadelphia to New York City. You can get a quote online at $200 and up. So you may want to connect once you have a system here and a system there. And one connection compared to none is a far bigger difference than a big connection compared to a little one. So once you have a connection, you could do immediate dispatch for a pretty low cost, a pretty high rate of speed. You know, the local system going to operate at 30 miles an hour, 50 kilometers per hour. The long distance could probably operate starting at 100 kilometers per hour and go up from there probably to 200 without really, you know, becoming energetic and wasteful. And so, but when you connect the two, that's your high priority movement. What about I want to go from Philly to New York? I don't want to spend a lot, but I don't care if it takes a day. Then imagine a tractor trailer, and the trailer on it looks very much like a honeycomb. And it pulls up next to what looks very much like a multiple track system. And it waits there, and everything destined for New York City pulls in on a line and fills this honeycomb. And once every couple of hours, a truck dispatches for New York City, and it pulls up to New York City. And out of this honeycomb, instead of firing missiles in the middle of a war, you're firing payloads down the line. It takes a long time to go through the detail of, 11 years of creative work where I realized, hey, you can do this. And it's not just a strategy. I'm building it. I'm making the tactical decisions on how it will work. The mechanical, the electrical, the controls, all of it. And so I don't know if we're going to be able to run that little quick demo. It doesn't really demonstrate system operation, but
Andre, do you have that film? Can you try to play it somehow?
No, I don't have it now. So it's impossible now. I'm sorry.
Well, then they're going to give the audience a reason to come back someday.
Yeah.
Yes, definitely.
That's what
definitely.
I want to say.
We are going to repeat the program in Polish and just say sort of like explain what we talked about. I think we covered most of what we wanted to express in general. It was pleasure. And I'm happy that we had this conversation in front of everybody. Because why should we just talk per Skype or whatever, where we can have other people a chance to participate?
Did we leave any significant questions? Any significant concerns? Especially skeptical.
Yeah.
Did we leave anything totally untouched? Because
there'll be certainly a lot of things like of course somebody will ask about costs.
We didn't touch that at all. Let's just go very quickly. Long haul across the ocean. I want to just say very quickly, there's a phrase that most of us have heard. It's called economies of scale. We've heard that. And what's the connotation? Bigger is cheaper. But this is not true. If anybody had built an ultra-large crude carrier 200 years ago, they would have lost everything. And Isambard Kingdom Brunel, a 19th century engineer in England, was behind the construction of the Great Eastern and the Great Western. One of them was a success, the smaller one. One of them was a commercial failure, the bigger one. It was too big. There was not enough demand for it. And it was smaller than most of the ships on the ocean today. It wound up making commercial success with its fourth owner. It was employed in the laying of the first successful transatlantic telegraph after the U.S. Civil War. Like I said, I can't remember if it's the Great Western or Great East. But the real economy is not in scale. It's in ratio. If you can spend $1 in capital that saves every year $10 in operations and maintenance costs, now you have economy. Now you have something that was worth the investment. If you spend $20 in capital and it only saves you 50 cents, now you have subsidized, well, you fill in the blank. So the cost of ocean freight is on the order of 1 penny per ton mile. Maybe a little more, maybe a little less. It depends. The cost of North American rail freight, which is among the most cost effective, for reasons of standardization and other, is about 2 cents per ton mile. The cost of North American long-haul city-to-city truckload shipping is, the average cost of U.S. long-haul trucking is about 26 cents per ton mile. And these can be accessed at the Bureau of Transportation Statistics, expressing them in ton miles, English units that's typically in the U.S. is used. A short ton, so not 1,000 kilograms, not 2,205 pounds, 2,000 pounds. The cost of parcel shipping starts at $2,000 per ton mile, not pennies, thousands of dollars per ton mile. Now, I've done a long and thorough analysis, and I know there's a capital upfront cost. Believe me, I know the upfront development effort, especially at least the one-man effort. And the final total cost of ownership, operations, capital payoff of this means of moving things on an average of 5 or 10 pounds at a time is going to come to about $1 or $2 per ton mile. Now, this is not as cheap as trucking or rail, but it is far cheaper than the waitress, the UPS man, the Amazon, or any Uber Eats, or any, I'll mention by brand the leader in the sidewalk bot, Starship. Starship consumes 40 watt hours per mile. I'm sorry, that's not metric. I had it converted to metric, but I'm so used to the English. I'm sorry, you convert later. And their charges are, I believe, $2 per delivery, and their typical delivery doesn't even go a mile. And if it's fully loaded, it can carry 20 pounds. So their costs are hundreds of dollars per ton mile. And drones, nothing uses more energy than a helicopter. And when the people even offer their best marketing for it, if you analyze what they're saying their costs are and what they're carrying and how far, they're claiming numbers in the $50 per ton mile range. And they have a tendency to paint a rosy picture. I believe their costs will come in around $100 a ton mile, or 200, somewhere in that range. And here, I know it's a lot to calculate. You have the installation, but just like a bridge goes across the river, and to pay the toll and drive across is cheaper than the boat ever was or ever will be, even though the bridge costs 100 times more than any boat. Yes. So somebody asked about the cost, and it deserved a little treatment, and at least I hope that's a good takeoff point. And don't take my word for it. Go ahead and scratch and really compare the numbers and check them and see how they look. I think you'll find that tap water is cheaper than bottled water.
Yes, definitely. It's been well. I'm an economist myself, so at the first glance, the idea seemed brilliant because I can see the numbers. I mean, the guy on a bicycle will be more expensive than a parcel in a tube that travels by itself, and especially if there is parcel after parcel, if there is not the traditional pneumatic post, but you have like the using the capacity of the tube to the maximum.
I'm expecting a system throughput on average to peak at around 8,000 vehicle miles per mile of one-way lane. That would be about where I expect, without really, having capital to tune and optimize, which a lane of traffic on the road typically chokes up at about 2,000 vehicle miles per mile of lane. About 2,000 cars will pass 1 point in an hour. I expect to be able to get to 8,000 on my own and subsequently probably higher, but where will the cutoff be? I couldn't say. So one other little metric. Sorry to squeeze that in, but
yes, I was calculating that with depending on speed, I think with 50 kilometers per hour, you would get about 1 million vehicles per more than 1 million vehicles per 24 hours. It just assuming that there will be sort of like bumper to bumper.
yeah, that's
most probably.
Is that the same? I'm thinking I'm going to get to 8,000 per hour. So 24 times 8,000, 24 times 8 is 200. So I'm only promising 200,000 per 24 hours. But like I said, it's probably ultimately going to go higher. So I think we're not that far apart, right? A factor of 5 for order of magnitude estimation. That's
because I was estimating it was like one. It's if you have the speed. It all depends on the speed, of course, because then and well how efficient you are, is sort of like squeezing them together.
I guess I was just you were talking one line, like your main expressway circuit, and I was kind of, I have a network and there's a weave and average throughput reaching 8,000. So I think we're really on exactly the same number. On a high throughput line, you would get more, as they did in pneumatics. In pneumatics, for the long haul sort of conveyor circuit between buildings, they would put them in. I can't remember the headways. There was an 8-second headway between capsules to prevent, two blocking, but I can't remember what portion of the system that was. A lot of things to consider and cover, and a lot of places for people to think that they're jumping to conclusions. No, I'm trudging along.
Okay, guys.
Yes.
So I think we got a very sophisticated presentation, very interesting, and if we will get more viewers, so we will continue. And of course, as Tomek said, we prepared the Polish version description. And by the way, I already spoke to Miłka Stępień, which is very interesting. She's ecologist and very interesting about such inventors and ideas. So she is invited for the next discuss, and she is very, how to say, clever and looking forward girl, and they know each other. I mean, Tomek and Miłka. For today, I want to say thank you very much. It was really big pleasure to meet you, Robert, to meet your idea. And for Tomek, what was much better and easier, because your English is much better. This is one thing. And you were talking about the system, which is already in your head. I was just listening, and I will spend some hours to come to the links I presented, and so I'll be more informed about. And as I said, thank you very much, Robert, for your time. Thank you.
Thank you. Bardzo dziękuję.
To my dziękujemy. And we are always asking why. Dlaczego? So you try to explain us why it is cheaper, why it is better, why it's environment safe, or how we
friendly,
call it?
Yes.
Friendly, environment friendly.
Yes.
Exactly.
And
not
COVID-proof. COVID-proof as well.
Exactly. Okay, guys. So I think around 10 days, I suppose, to meet again. Our program, our broadcast will be transferred on YouTube, video code, and the broadcast named Dlaczego. And afterwards, we will repeat on the other friends seaside. Okay, thank you, guys. And it was really pleasure time to spend together. Thank you.
Thank you.